do. So the good news is we do have a little bit of time, not much. And I'm not talking about today, okay? I'm talking about in the next few sessions, because some of you asked me some questions, and I would like to explain. I hate to have you guys walk out of the room with a half understanding, or total misunderstanding, or thinking that you understand when you don't understand, or not knowing you don't know, and all that stuff. Okay, now let me just put some numbers to that calendar spread thing, which is really quite interesting. And I am wondering how many such examples you can find in China. Okay. Now, so let's just say there's a March contract and there's a February contract for the CAC, and the spot price. Am I recording this? Yes. And the spot price right now is 100. And the way I price the March contract is it's just the spot price plus the interest minus the dividend. Now, like I said before, very, very important point. The dividend is a projection, okay? No one says that this is guaranteed, okay? It's the market's estimation until they actually announce, okay? If you say $3 and then they announce $3, then yes, then the price will not change. But otherwise, there will be an adjustment. So before we know, okay, this $3 is just an assumption. Now, if you put that all together, so the March contract will be priced at 98, 101 minus 3. Okay. Now, for the February contract, I'm just using really simple stuff here. So the spot price plus the interest rate, and I'm saying the interest cost is 75 cents. Okay. I'm not really bothering with the percentages and so on. Now, the February one does not have a dividend, so I don't include that in the price. So the February futures should be priced at around $100.75. Okay, now this is before. Now imagine they make an announcement. SocGen made a huge catastrophic loss, and the whole market panicked. And as a result, the stock index future dropped 5% from 100 to 95. Now you can still price the future, especially the February one. This one will be 95, 75. Okay, and the March contract will be priced at 95 plus 1 minus 3, which is 93. Now here's the problem. Here's the problem. This $3 dividend, as I said before, this is an assumption. This is a market projection for what dividends will be paid by any company that is in that stock index portfolio basket during that time. And although we said it might be $3 before, we now know there is no way that SocGen can pay you anything. So if you were to strike that off, the fair price at that moment in time should really be 96. Okay. So some traders saw the opportunity. Hold on a second, this is not priced correctly. Now, like I was saying to some of you, you could just go in and you just go long. You just go long the March contract and hoping that it will just jump back to 96. But why take that risk? Because you don't know if it's going to fall further. Okay, so you want to go long this one, and you go short the February one, and as a result, you actually have hedged your risk on the spot, because you're long the spot, you're short the spot. So you just have the interest rate risk, which is very little, and then this whopping big dividend that shouldn't really be here. Okay, when the adjustment comes, when people see that it shouldn't be 93, maybe by that time both of these have dropped to 80, but you don't care because you're long one and you're short the other. All you care is that this one gets repriced properly. In other words, the gap between them should not be the gap between this and this. It should be the gap between this and this. Is everyone okay with that? No? If not, then this is recorded. If you want to take a picture, it's fine. But you see it at home. Maybe you can go home and once you listen to the commentary again, I think you will understand. Okay. Now let me quickly get to another part, which I think is important. Now this is a simple point, and but a very important one. And now this is an option, as you know. This is a graph for an option payoff. It's a call option, and if you are studying very elementary derivative classes, they all tell you that. I'm sorry, this is supposed to be a straight line. Let me start again. It's hard. Hey, that's better. Okay. Now, you all know from your undergrad that this is a classic call option. Call option. Payoff diagram. And this is what happens at maturity. So if you had something with a call option at a strike of, let's say, 100, and then at maturity, if the price was 105, okay, then of course you get to make $5. Okay, so let's say, so the x-axis is the price of the underlying, okay, and then you make $5. That's your profit. Now, this is the worth or the value of your option right at the end after the option expired. So only three things can happen. Either it's here, it's out of the money, or it's in the money, or it's at the money. You'll be very lucky if that happens. I have seen it, but not very often. Right on the dot. Okay. The thing to remember is there is another side to this, and that is when what color is this? Is it the same color? Color and thickness. What color would you like? Okay. What's this? Purple? No. Huh? Green. Okay. Green. Green, he says. Now, during the life of the option, orange is the new black indeed. You're a Netflix subscriber. Now, is this orange? No, this is green. Now, during the life of the option, let's say 1 month, 2 months, 3 months, all else being constant, okay? Bankers love to say that. All else being constant except the passage of time. Your option value should look something like this. And the further away you are from maturity, the more elevated it is. And in fact, if you take the extreme case, at maturity, it's just 2 straight lines, and then very, very slowly it becomes a curve, and the curvature is kind of decreasing, if you know what I mean. And then it's like you are pulling. If you can imagine, you are pulling this piece of string slowly. Or if you go the other way, as you get closer and closer to maturity, it sinks back to earth, and it really wants to go home. So this might be, let's just imagine, this might be 2 months to maturity. This can be 1 month to maturity. And when you are really, really close, so I'll use a red color. When you're really, really close, and that's quite hard to draw, right? It might be something like this. I almost have to hold my breath when I'm drawing this. It's so hard. You know, you see my point, right? Yeah? So this, can you even see that?
Yes.
This might be, let's just say 1 day, okay? 1 day to maturity. So it's kind of like, there are a lot of different ways you can think of that. You can think of that as, it's like a balloon, and it's gradually losing air. Or it's like a souffle. You know what souffle is? It's a dessert. Is that the accent? Or is it the other way? Does anyone speak French here? Yeah. So it's very nice, actually. Okay. Lots of calories. So when you bake a souffle, when it's presented to you, it's kind of like this, and then gradually it will sink. Okay. Or like a balloon. Now this, of course, is just different ways to describe the grand concept of time decay, which is just like time is in the center of everything that Einstein does. So time decay really is at the heart of option pricing, as you will see in the coming weeks. Okay. Now I have here. Now just remember that very simple but very important point, because we're going to keep coming back to it. Okay. Now here I just have a simple. I should have gone a more up-to-date version, but this is just a Bloomberg printout of options that you can buy or sell on Apple at a particular moment in time. So how do you reach this? How you can go to Bloomberg, and if you type, I'll even show you how to do that. If you go, so Apple is AAPL, for example. So you go US, you go equity, EQUITY, and you go OMON, OMON. That stands for option monitor. Now this is a very handy, it's pretty cool function. So all it is showing you, I think this was just a page I cut out sometime in May 2012. So these are actually these are monthly options. Okay, so every month there is an expiry, and there are call options on one side and put option on another side. Now there are bids and there are offers, and here is when it gets interesting. So these are what the price makers have put down. So someone is happy to buy at 24.4 for a call option with a strike of 600. At that time, the spot price was 610. Okay? And somebody was happy to sell at 24.75. They even tell you the implied volatility. So more on that later. Okay? Volume and open interest. Now someone asked me an interesting question. Okay? So let's say that is the market right now. Okay? So there are people on one side, so let's say on those guys over there, they are happy to buy this call at 24.40. And all of you guys over here are happy to sell at 24.75. Okay. Now, if nobody else comes along, then you guys will just be sitting and will just be waiting for each other, and nothing will happen. Okay. But if someone comes along and suddenly say, okay, I am happy to buy at 24.50, which is higher than the 50. Okay. Now, what do you think would happen? What would happen is when you say I buy, I am happy to buy. Okay, I enter a bid for call options on Apple, maturity May 19, strike 600. I'm happy to buy at 24.50. Your price will replace this one. And as a result, so at that moment in time, like I said, you are the price maker. And then you can see that it's tightened. Yeah? So it's tightened. And if there's someone out on the street and they actually want to sell, but they don't want to sell at this price, if they're happy to sell at 24.50, okay, then they will hit your bid, for example. Okay. So that's how that works. Okay. Just one moment. Hello?
Daddy?
Hello?
Can you tell Cheetah?
Oh, Felix, I'm sorry, I'm busy.
Because I'm gonna play iPad with my friends.
All right. You tell her to enter the pin. Okay. I'm busy. I'm sorry. Okay. Bye. Yeah. Sorry, I have to answer that in case there are emergencies. Okay. But that one was not an emergency. He wanted to know the pin to the iPad. So, sorry about that. Yeah. Other phone calls I don't answer. Right? Okay. Hello?
Sir?
Yeah.
Are you Felix asked me to talk to you?
No, I'm busy. Sorry.
Okay, I'm sorry, sir.
Okay. Let me deal with this first, and then maybe I'll go back to this page either later today or next time. Okay. Now here is put call parity. The classic definition of put call parity is the call price, which is little c, plus the discounted strike is equal to the put price plus the spot. Now that's the textbook definition of put call parity. You are all aware of that, right? Yeah. And what Tobias has done is to say that the discounted strike is equal to the strike price minus the interest on the strike. Now, strictly speaking, I guess you could argue that this is not exactly correct. I'll tell you why it's not exactly correct. So if the strike was 100, let's say, okay, and you have and the discount rate was 3%. So when you discount it back, so discount rate was 3%, and when you discount it back, So what's 100 divided by 103? I'm not using continuous discounting, just very simple discounting. What's 100 divided by 103? 97.087. So 90, thank you, 0.087. Now, so when you discount, don't worry about the continuous compounding, but it will be approximately this, okay? Now, actually, when you discount a strike back, okay, so what they're saying is it's equal to strike minus thank you, interest on strike, but actually I'll write that out properly, okay, minus interest on strike. But actually, if you look carefully, it should be 100 minus the interest on 97.087, okay, not on the strike, isn't it? Because you discount it back by 3%, then naturally when you compound it up 3%, you get. So strictly speaking, okay, you could argue that this is kind of a little bit of an approximation, okay, but let's not worry too much about that for now, okay, just take that, but at least you know how we got from here to here, right? So the discounted strike, you take that back. If you just imagine, anyway, it's around $3. It's a little far away. Never mind. Right? So you have a strike minus the interest on the strike is equal to put plus the spot. So when you take the put to the other side and you take this lot over there, it becomes spot minus. This is just rearranging, okay? So end up, you have call minus put is spot plus interest on the strike minus the strike. Now, this is what I would ask you to remember, okay? It's the first time this morning I asked you to remember something, right? Correct? Yeah. I know that Tobias calls this one C minus P is equal to F minus X. Strictly speaking, the F here, he means the spot plus the interest on it. This is not really the forward of the future. It is not, okay? I'll tell you that right now, okay? So I call it the Tobias-Hexter forward, okay? But in reality, this one is correct. As long as you actually accept this approximation here, okay? So I already told you it's not exactly right, but it doesn't matter. Is everyone okay with that? Yeah? So it's not hard to remember. You know, when I was dealing with banking clients, one of the client I remember very, very clearly with the most colorful portfolio of FX transactions was Cathay Pacific, because they had revenue from all over the place, from Japan, Singapore, Malaysia, Thailand, Vietnam, Canada, US, all the European countries, and they always had the most colorful portfolio of foreign exchange that they wanted to deal with us. So that I always remember Cathay Pacific, FX, and I never forgot. This is how you can remember. I'm not advertising for that, okay? You know what I mean? Yeah. But don't worry that, like I said, F here stands for spot plus interest on strike. Okay? So that is correct. Okay? But whether you insist on calling this the future or the Soviet's future. Okay. And then, well, this is just restating. Actually, why do I need this page? I'm just restating what I just said. Now, let me, is everyone okay? Yeah? Now, do you, yes?
Do we need to add the dividends?
Very good question. Actually, I'll tell you why it's a good question, because in one of your, in one of the questions in set 1, there is actually a question that requires you to apply a dividend input. So thank you for asking me. I would have remembered when we get to that question, but when there is a dividend, okay, you simply modify it. You simply modify it. Call minus put is equal to spot plus interest on strike minus what? Big D, Big Daddy, okay? Minus strike. That's it. So if dividend is 0, you don't worry, okay? But otherwise, you just put the D. And there is a question a little later on, and I can show you. Okay? Thank you for that question. Is it okay? Yeah. Now, do you want to know? Are you okay with leverage ETFs?
No.
All right. Now I have I've written some notes here on this, but I don't think I want to. I don't want to go through this. You can go home and read it. But what I do want to do is make some references to. Hold on a second. Now, I advise you to go to the actual lecture. Is that lecture 6? Is it? Roughly what page is it?
25.
Now look at theta. Ah, here we go. Okay, now, yes. The problem with leveraged ETFs is as follows. Now, I would advise you to, because there's a simple example in there, which is quite good. And I was doing some scribblings last night. See if I can find it here. I think this is the one. Oops, it's okay. How do I turn that around? How do I rotate? Okay, so the point about leveraged ETFs is, first of all, they are ETFs, exchange traded funds, and there are a lot of them out in the market. And the point about leveraged ETFs is that you can make a $100 investment, and if there was no leverage, then if market goes up 1%, you make $1. You make 1%. With a leverage ETF, if the market goes up 1%, you can make 2%, okay, or 3%. And the way they do that, of course, is simply by leveraging. Now, here's the problem. The problem is the way they do this is such that if this is day 0, and this is day 1, and day 2, and day 3, okay? The way these ETFs work is if you buy on day 0, and 1 day has passed, and the market goes up 1%, you have made 2%. Okay. Now, if the day after, let's say it falls 1%, then someone who bought here, okay, would lose 2%. The problem is the guy who was here, okay, the performance of that guy is now all over the place. And the reason it's all over the place is because at the end of the day, they are rebalancing the portfolio so that on a daily basis, if you buy in the morning, sell at night, you will actually get 2 times the performance. But if you buy and you hold on day after day after day, after like 10, 15 times of rebalancing, it's just completely out of shape. You understand what I mean? Now that's the concept. Now I'll demonstrate to you how that comes about. Okay. Now this is actually consistent. I was just scribbling late last night, so sorry I rubbed off some crossed off. So this is consistent with the notes in your lecture. And so let's say there is a portfolio, and the portfolio was worth $1.4 billion. So your clients gave you $1.4 billion. Okay. Well, let's say you are mega rich. This is your portfolio, and one client, and it's worth $1.4 billion. Now, if you want to go to the futures market and buy futures contracts with an equivalent worth of $1.4 billion, so assuming that the market is 1,400 points and each contract is so it's $50 per point, so each contract is actually 70,000. So you're going to need 40,000 contracts. 40,000 contracts in order to have exposure, which is exactly 2 times of your current net asset value. Are you with me there? Okay, so this comes from, so this 2.8 is just so 40,000 contracts at $70,000 each, and 70,000 came from 1,400 points times $50 per point. Okay, so you have 40,000 contracts on day 1. Okay, now let's say on day 1 the market goes up by the market. Okay, so we're talking S&P, I believe. Okay, so the market goes up by 1%. You can see what's happened to you. So this is the amount of futures contracts you have, which is 2 times your actual wealth. So if it goes up 1%, of course it's going to go up to $2.828 billion. Okay? So now your NAV is your NAV when you started, plus that little bit of profit that you have made, which is $0.028 billion. Now that little $0.028 just came from this profit here. Okay? So this is the profit that you made in 1 day. Now, here's the problem. Now, what you want is and at the end of this day, what you want is 2 times this exposure. Okay, so you want to have enough futures contracts such that the value would be equal to 2.856 billion. Right now, if you do nothing, your futures position is actually only 2.828. So you are actually a little bit short. In other words, if you do nothing, then as the market goes up and down, for the next day, you are not going to have 2 times the performance. Okay, so you need to rebalance. How? Now, if you refer to the lecture, they do tell you how to rebalance. So I won't go into the detailed numbers of that. In any case, you need to buy a further 396 contracts, okay, in order to get an exposure equivalent to this amount. Now, suppose the day after, market drops 0.99%. Now, why do I say 0.99? Because I do this on purpose. Okay, so 100, if it goes up 1%, it goes to 101. But if you wanted to go back down to exactly 100, this is a rise of 1%. This is a fall of approximately 0.99. I mean, you can add more decimals if you like. Okay. So here's the problem. When you have these contracts, and the market falls by 0.99, you can see that your net wealth actually becomes your net wealth of the day before, okay, minus the loss that you have. Now, where did this 0.02827 come from? This is simply your new position multiplied by 99.01. Okay. So I did that on purpose because if you go up 1% and if you come back down 1%, technically you don't end up where you are. So on purpose I made it go up 1% and go down a little bit less. So you are supposed to be back to exactly where you are. Now here's the problem. You are not. You are not back to exactly where you are. You have lost a little bit of money. You started with 1.4 billion, now you're a little bit down. Okay? The reason that happens, ladies and gentlemen, as I said, the reason that happened is that when the market went up 1% on that day, you actually had to rebalance. And you had to rebalance because for the next day, you want your original NAV to perform, but you also want your profit to perform, okay? So you can earn profit on profit. So to do that, you added more contracts, and then if it goes the other way, then your problem starts, okay? Now, this is quite well known with leveraged ETFs of all kinds, and it's I think the term for it is called beta slippage, SLIPPAGE. And the point about this exercise is, one, do you actually understand what's going on here, okay? And two, do you know how to rebalance the portfolio, knowing that, you know, it ends up giving you a rather poor result, but that's beside the point, okay? Do you know how, if you write an Excel spreadsheet, it's very easy. You write 3 or 4 cells and you can drag and drop them all the way down. Very, very simple. Okay? So you need to know how to do the rebalancing. And I think the lecture notes, page 36, or is it 26, they already gave a very good example. Together with what I've shown you here, it should be okay. And as I recall, what you are asked, is this the assignment? Yeah? So what you need to do is, well, a few things. So task 1 is to run a Monte Carlo simulation for S&P spot prices. Now that's a simple task. Now this is how people would price options in the age of the dinosaurs. Okay. So this is time. So let's say your starting price right now, we said 1,400. So I'll keep using that. Okay. So you just use your Excel to do a random simulation of 10,000 paths. You can write a little VBA if you feel adventurous, and let's say you have a call option here. So this is this one is at the money, but let's say your call strike was 1,500. It doesn't matter. Okay, let's just say it is. Then, and this is maturity, and then so around. So this is maturity. So you would find that basically all of these outcomes are in the money. So these outcomes are profitable, right? So what you do is you just discount them all back. But in fact, if you assume interest rate to be 0, you don't even need to do the discounting, right? It will make life easier for you. So now, this is just like if you go to a casino and you play some games, you simulate the roulette a million times. You want to try and bet on when the number 17 comes up. You would find that on average it's 1/36 or whatever. Okay, so this is the same thing. So all of these are not profitable, and then these payoffs you just take an average. Everyone is okay with that? Yeah. Now that's number 1. Okay, the first task. So what you have here, congratulations, okay, is an option pricer. Okay? Although it's not really a very sophisticated one. Now you might wonder, well, how do I generate these parts? The key parameter is actually your volatility. Okay? So depending on what that input is, you get different results. And do you generate it over a year or what? I can't remember now. Huh?
156 trading days.
Right. So what you can do is you actually can generate a daily. You can generate a daily movement based on let's say the vol of the annual vol is, let's say if it's 16, okay, what's the daily volatility? Daily is equal to the annual divided by square root of t, which is the number of days. So it's divided by the square root of 256, which is 16. So the daily would be 1%. So what you need to do is you use the random function. There's a very simple standard way to put together a random process, which I think some of you should know. You start with the probability and you work back to see what is the return. Okay. So anyway. So you do that, and now that you've done task 1, then what you are asked to do is you have to price a straddle on S&P, and you have to price, which is just long call and long put, okay? And then you price a straddle on a leverage ETF, and you price a straddle on a leverage inverse ETF. Now, the point here is, although these ETFs have doubled the exposure, so you would think that the price of the option, first of all, is more expensive, okay? You would think that it should be double, but when you use this simulation, you find that the end result is very, very different from what you expect because of that beta slippage problem that I just told you. It's just completely out of shape. So we just asked you to compare the theoretical price that you can get. Now, what do we mean by theoretical price? To see how the average, I think you can simply, all right, the simplest way, for example, is this is one of my favorite websites. I don't need to tell you what it does. Okay, so a theoretical price of something. Let's say the S&P, and you use 16 vol. So you get a theoretical price for. I'm just using 100. It doesn't matter. Okay, and then days until expiration. Is this trading days? I think it's calendar days. So 365. So you get a price. So this will be the theoretical price for your S&P. Now, your 2 times leverage ETF, in theory, should have a vol of 32. Okay, so that's the theoretical value. I can guarantee you that it's nowhere near. So once you've done your simulation and you compare it with this, you find out, wow, they are so different, okay? And you can even go back, and if you want to be quite adventurous, you can go back and you take the simulated price, and if you assume that to be correct, you then come back here, and then you start playing around with the volatility, and you see, okay, what volatility will give me that price? Okay, so that's another way to look at it. Okay, now task 3 actually is something similar, but instead of pricing straddles, I think you're pricing call spreads or something. Please do this for. No, not call spreads. You just 6 different options. So out of the money call, out of the money puts for the standard non-leverage ETF, and then the leverage ETF and the leverage inverse ETF. Okay, and you would find that when you use different volatilities, when volatility increases in your simulation, the more volatile it is, the more out of shape it becomes. Okay. Oops. I shouldn't have told you that. I have. Okay? Is everyone okay with that? Yeah? Now, I think we are near the end of today's session. I would have liked to start on those questions, the question set, but we will get around to that. One other thing I have not covered actually is slide 35, but we'll get around to doing that next time. Okay. Now, I think I've taken enough of your time. This stuff it is interesting, but I understand if it's heavy. So I hope that will help you. And we will meet again on Sunday, and I will let you know the venue. It will be somewhere around here. I think it's opposite, some room on the other side. So in the meantime, please do write to me and help us to help you. Okay. If there's anything else you don't understand, is everyone okay? Is everyone okay with the assignment number 2? First of all, why don't you tell me now, and we can share some answers. Is there somebody wants to ask a question on assignment 2? Do you? Yeah. No, go on.
I've actually checked out the Excel file provided by Tobias, and I saw that. Let me check it out.
What Excel file did he provide you?
There's one example of doing the Monte Carlo simulation.
Ah, right. Yeah, but as soon as you hit F9, it becomes something else. No?
And I don't know why there's this.
What?
He calculated the daily movement by using this formula, but he divided it by 1,600 instead of 16.
It's just a decimal. Because he wants to get the basis points. Yeah, you can use the
Why is there 2 zeros?
why is it 1600?
Yeah.
Well, I don't know if the ball is really 16% or whether it's 16. Well, anyway, for column C, all those are percentage movements. So 0.0062 would mean 62 basis points. So 00, if you convert that to a percentage, that means 62 basis points of movements. It means 0.62%. Yeah. You see, I wouldn't worry too much about that. If you put 16% up there in the formula bar, I don't know if this actually you type it in as 16 or what. This is the problem sometimes with Excel. Sometimes you have to type 0.16. Sometimes you type 16 because the cell is formatted as a percentage input. But if you were to, anyway, so for column C, all those things that you are seeing, okay, if you convert all these to percentages, so that would be 1.35%, 1.22%. So that kind of number makes sense to me. Okay. That should be it. Yeah. No. Just convert them to percentages. Just reformat until they become percentages. Yeah. And then you'll be okay. Actually, I'm instead of don't worry about the formula, but ask yourself whether these prices are making sense to you if you have a 1% implied goal for daily movement. And I think they do make sense. Okay? Yes. Yes.
How to use the option pricer you showed in the website to get the theoretical price of the W versus BTS?
Okay. Maybe I went too quickly just now. The way you would do that, now, the very, very simple way to think about it is if your S&P is priced with a 16 vol, And if I tell you that you now have something which is 2 times as volatile, okay, you could, in theory, use 32. But we know that it won't. That's the theoretical. Okay, that is the theoretical. But we know that in reality, it will be far away from that.
But how do you price the inverse ETF?
Same.
Same.
Yeah, it's just inverse ETF. Okay, when you price a call option on an inverse ETF, it would be like pricing a put on the S, because you will make money only if it goes down. Okay, and in theory, if I tell you that, oh, there's this thing out there, every time someone makes $1, you should make 2. Okay, if that really was true, then I should be paying double. Right? Or now you can see that actually very, very elementary option pricing. So here, if I type 16, just watch what it shows as the price. So it's $8.32. Can you see that? Yeah, right. Now if I put 32 in here, 32. All that happens is the price will double. So it should now be 16.64. I'm looking at the call price. Oh, it's not. Because I have interest rates. Because it's causing a bias. So if I set all these to 0, just wipe them all off. 16. Because it's not exactly forward and the spot are different, but now it's 637, okay, and if I change the vol to 32, it should be double. Don't worry about the 1 or 2 cents. Okay. All right. Yes.
Question about the days and like duration. Is it does it only is it just the trading days or?
Well, actually, for this website, it depends on what they do. I'm just pricing it.
If we should look for 256 days, then it will be different.
Well,
They take 1 year and they already.
I know. Yeah. Now, for what you do, you simulate that over 256 days. No, it wouldn't make any difference. Because if you use a price, you don't have to use this one, okay? But when you use a pricer, any pricer, okay? If there are 2 pricers, one of them works on calendar day basis, and another one works on trading day basis. As long as you put in the same parameters, they will give you the same price. Okay.
We just mention it then.
Yeah.
If we have to put in the results, we should mention how we find.
Yeah. But for your simulation, you should use trading days, definitely. Yeah. You know what? We got a small issue. I see that there are people waiting out there.
Sam, this website, if you click the about, it states that it uses the calendar days.
Oh, thank you. Yeah, this is a pretty handy. It's been my friend for the last 4 years. I'm going to have to let you go because some people are waiting out there, and now I will produce this.